Hi, my name is Tejas Sabu and I'm an intern with the Digital Vaccine Labs team. And this summer I worked on an IPS filter data categorization project. I'm a rising sophomore studying computer science at UT Austin, and I was also in UT's Inventors program sponsored by Trend Micro this past spring. And in the Inventors practicum, my team and I worked on a tool to monitor the performance of microservices. I enjoy hiking, camping, painting, and playing ping pong. Project overview. So the IPS devices cannot activate every filter because this would significantly slow down our customers' network speeds. Additionally, the Customer Security Operations Center and network team oftentimes does not know what software is on their network, so this makes a challenge for us when we're trying to decide which filters to activate for them. So it's very important for us to take a customer-focused approach to activate only the most relevant filters for each individual customer. And we did this by categorizing over 20,000 filters by their product type and industry vertical. And along the process, we corrected and updated the filter metadata, specifically the vendor and product reference tags. So I won't dive deeply into all of my steps, but I'll highlight some of the most important ones. I use Python's pandas library a lot, basically every single day in my internship, to read and create spreadsheets as well as manipulate data frames. And then since I was dealing with 20,000 data points of filters, it was very important to reduce this and make it a manageable workload. So I used a lot of different approaches, but my most successful one was using Python's FuzzyWuzzy library, and I use that to group similar vendors and products together and find clusters of that. And then by doing this, along with other techniques, I was able to reduce the workload from 20,000 filters to, I believe it was around 1,800 unique vendor product combinations. So this significantly reduce the manual review process as well. Also worked with a lot of APIs throughout the project, and the most useful one was using Google's Knowledge Graph API, and I used that to get data on every single vendor product. And then after I had that information, I got the product type and industry vertical for the vendor products, and then tied that all back to the filter ID, and then we're going to update all this information in SIGKB. So I used a lot of tools and technologies this summer, and I coded in Python primarily, used a lot of data science and natural language processing libraries, a couple algorithms and APIs, and also got to work with a lot of trends tools and use SIGKB a lot as well. So now for the cool stuff, the demo. So FuzzyWuzzy filter metadata correction, this was part of a mini project that evolved out of my project. So when I was looking through all the filter metadata, specifically the product reference tags and the vendor reference tags, I noticed that a lot of them had very similar duplicates. So they'd be off by a couple letters and have some versioning, and there'd be a lot of typos as well. So I thought it'd be a really good idea to correct all this information, because if the vendor and product information is correct, that's what we're using when we're trying to decide which filters to activate for a customer. So if one of them, if the vendor tag is misspelled like it is right here, the customer might not have that filter activated. So that would cause potential problems in the future. So what I did was I used Python's FuzzyWuzzy library, which is a library that uses fuzzy logic for string similarity. So I just had a simple example right here. I have a vendor 1, Microsoft, vendor 2, Microsoft with a misspelling, and this was actually directly from one of our filters, and this is missing the second O. And I'm calling the ratio method on both of these, and I'm printing that score, so we get a score of 93. And this helps us gauge potential vendors and products that are misspelled, and doing this also helps us group them together and significantly reduce the workload. And with FuzzyWuzzy, you can also do a lot of other techniques. So comparing strings directly, comparing partial strings, tokenized strings, or even comparing strings when their versions are the words are out of order. So this was really useful for that. The Google Knowledge Graph API. So I won't go into the technical implementation details on this, but essentially when I was looking at the vendor product combinations, I'd cut that down to 1,800 vendor products, and I had to try to find a way to automate the process of retrieving information from the internet and categorizing them. So I decided a good way to categorize them would be by their product type, so some sort of software category, which is challenging because there isn't a concrete set of systems used to categorize software as there is for other industries. So I had to experiment with that a bit, and also decided to do the industry vertical for that. So what I did was I just searched a couple dozen of the vendor product combinations on Google, and I realized oftentimes I'd be using this object on the right side of the screen right here. So you guys might have seen this before too. And I thought it might be a good idea to look into this, and I found out it's called Knowledge Panel, and Google actually has a knowledge graph API to retrieve this information. So it's able to automate the process of getting information for all the 1,800 vendor products really fast. So I would get information such as Google's name for it, which we can use to verify that Google's match is correct, description and category, a detailed description, some links, and a lot of other useful data that was very helpful in categorizing. And now we put everything together in a very seamless and intuitive solution to categorize the actual filters. So here we're looking at SIGKB, which is our trends filter writing tool, and we're looking at a Microsoft Internet Explorer filter. So we have the product Microsoft Internet Explorer and vendor Microsoft, and that's the information I pulled out of SIGKB initially to get the product and vendor metadata to categorize them. And here I added the feature where we have a product type reference tag and an industry vertical reference tag. So for Microsoft Internet Explorer, we're adding a product type of web browser and an industry vertical of internet software. So when you're on SIGKB, you can pull out all of the web browsers, all the internet software, all the banking industries, and all the different examples that we have. And that will significantly that'll help us make sure that the customers have only the filters that they need and not additional filters, because when they have additional filters, it will be checking unnecessary filters, which slows everything down. So it's very important to make sure we have coverage on everything they need, but not too many. And what's going to happen is the DV Labs team is going to be using this product type and industry vertical on all of the filters moving forward. And my project was focused primarily on updating this information for the 20,000 filters we already have. So we have a script to run that automates the process of adding this information. And in the process, we're also going to fix all the product data and the vendor data. So throughout this project, since it's so open-ended, I had to try a lot of different things and experimented a lot. So I realized that some things will work, some things won't, and some things will work but might take a while or won't work as well as you'd like them to. So because of this, my biggest takeaway from that was to learn how to get something to work and get a proof of concept out as fast as possible so you can find out, will this work in the time frame we need, and what is the scope of the impact, so that way you can gauge how to invest your time and prioritize your time. So going off of that previous slide, one of my biggest takeaways, as my mentor said, it was to fail fast. And it was also very inspiring to work with Trend Micro and the DV Labs team. I was given a lot of freedom and flexibility with my project, and the potential for impact is really great. So I got a good sense of Trend's culture and emphasis on collaboration and teamwork, as well as innovation. So that was really fun. I also got a lot of technical takeaways, as I mentioned earlier, but also got the chance to work on a lot of cybersecurity related tasks. This was really cool and unique, not something you really get to do in school. So I actually got to ship an IPS filter in my first few weeks of the internship. I learned a lot of irregular expressions in the process and just how cybersecurity works in general. So that's really cool. Also, this is my first foray into data science and analytics. So I haven't done much coding in Python before, and I just took some courses on Java this past year in school. So just going and learning this new language, I really noticed a lot of the similarities and learned how to adopt new languages, having a foundation in the logic behind computer science. So it's really nice how easily you can adopt new languages once you have a good foundations. So that was really good and a good learning experience moving forward. So I just want to give a special shout out to my intern mentor, Corey, and my intern buddy, Eric, and the rest of the DV Labs team. They were really helpful throughout this whole project and really supportive. Also want to thank Trend Micro as a whole for being so welcoming, and Reagan, Natalie, and Kathy for organizing such an incredible intern program despite all the challenges this summer. I had a lot of fun, and it was great to meet everyone virtually. Thank you.